So for finding the domain of a function, we want to find the largest set of all x values that can go into the function. For this first function, we can observe that it is a linear function. A linear function is a type of polynomial function. And for all polynomials, the domain is always all real numbers. We can write this in a bunch of ways. We can write this using the big special R. We can use interval notation to say from negative infinity to infinity. Those are probably the best two ways to represent that. For y equals ln of x, we can think about the domain of all logarithmic functions. We can draw a quick sketch of what this looks like, if that helps us. It has an intercept at x equals 1 at 0, and the graph is going to look something like this. And if we can remember this, we can sort of get that the domain in this case is always going to be x is greater than 0. The graph never actually touches the y-axis in this case. It never actually gets there. We can also represent this in interval notation, thinking about 0 as the lower bound and infinity as the upper bound for that domain. Now for this function, we have a couple things going on. First, we know that since we have a rational function, the denominator cannot be 0. We also know that since we have a radicand, we know that the radicand, x plus 3, cannot be negative. So for these two limits, we can find the largest possible set of values that are acceptable for this. So the denominator not being 0, we'll handle in just a second, but let's look at x plus 3 is greater than or equal to 0. If x plus 3 is greater than or equal to 0, then x is greater than or equal to negative 3. So we can think about this a little bit and say that we can draw a number line. So on this number line, we can color in the areas that we know are acceptable. So x is greater than or equal to negative 3, okay, which is great. So we know that according to this, it's greater than or equal to negative 3. So that means we'd expect to have at least an open circle on 3 and an arrow going to the right on the number line. So all of these values to the right of negative 3. The question is what goes on at negative 3. If x equals negative 3, and we look at the denominator, we are making the denominator equal to 0, which this requirement says is not possible. So this remains an open circle over negative 3. So as a result, the domain is going to be x is greater than negative 3 for this function. Or in interval notation, it's going to be negative 3 is the lower bound, and infinity is the upper